All right, welcome. This is Period Stats for Monday, April Fool's Day. And the April Fool's trick was actually played on me. Under full disclosure, I am doing this class solo with actually no class. I did it this morning, and once the class was over and I ended the meeting and was all set to record it and load it up on YouTube, it didn't happen. And I realized because I forgot to record. So that's why I have a sticky note down on my computer to remind me to always turn the record on. So I had a couple students absent today. So for their benefit and anyone else's viewing pleasure, when they're at home at night and no sports on TV, they may want to watch stats and how we can apply and use normal distribution to calculate probabilities of a multitude of scenarios. Let me go over the announcements for the folks that weren't here earlier today. Actually, it applies to one of you. There's a flexi quiz from last Wednesday, so you have to go into Blackboard now that it's up on operational and hit the link for the flexi quiz. And Mr. Daughtry, Mr. Hall, Mr. Tomlin, Mr. Walden, I don't have a score for you. And then somebody took it with the first name of I, last name of J, with the email of hh@gmail.com, and I have no earthly idea who that is. I can't put any of those letters together to figure out a name. They don't match with any of these guys. All right, so if you haven't taken it, make sure you take it here in the next couple of days. Don't be overly alarmed if you get some wrong answers that you are confident are correct. Flexi quiz is not super flexible in that if let's just say the correct answer is 0.23, and you type in 0.23, but the answer key has it listed as 0.23, it'll mark it wrong. Not to worry, I'll go in and manually rescore those. And when you check on it a couple of days after you take it, look at whatever your last problem is, and I'll put the final score there. All right, so no big issues. Now that Blackboard's up and running, just make sure that you have given me from last week section 6.2, problem set 2, and problem set 3. Place those in Dropbox if you haven't already done so. That addresses that. We're going to start section 6.4 on Monday. All right, so that's kind of the itinerary for what's next Monday. So if you got your textbook at home and want to get ahead of the power curve, you can take a look at that. I do have an IOU for you. You had three probability problems to calculate from Monday. Reference some IQ scores that we did on Monday, all right? And since you're not here, I'm gonna go through here and you're just gonna have to grade and check your own paper. But we're gonna calculate some probabilities of IQ scores. We've used this data a multitude of times. And to refresh your memory, the mean IQ is 100. The average IQ, or the mean, is 100. Remember, IQ is chronological age over your mental age, all right? So ideally, you always want to score at about 100 or slightly above it, all right? No matter what your age is, because there's different IQ scores depending on what your age is, all right? And the standard deviation is 16, and we've used that a multitude of times. So nothing new here. So you're going to need a couple things if you don't have them already in front of you. As a matter of fact, I don't, since I'm teaching this class for a second time. Let me grab that and we'll be right back with you. You'll want this handy dandy guide that we created on the last Friday. I think we were in class, because that tells you how to read the standard normal curve of just about any configuration that you'd run into. Not the exact values, but how to read the scenario. And you'll need what the textbook always refers to as table 3. And it's table 3 in appendix B of your textbook, or I gave you this one that I downloaded offline. And if you don't have this, you can download your own and print it. Just Google search standard normal probabilities, and you should find this one or probably a dozen others that are on there. The values there should be exactly the same. So you'll need this for the data and the values. You'll need this possibly as a reference, but if you're progressed far enough along, you may not even need that. So the first problem from last Monday is you had to calculate if someone is selected at random, what is the probability that they scored above 110 on the IQ test? All right, 110, which, hey, I'll take 110. So if you want to look at it visually, I'll put that over here. Let's see, we've got room. Yeah. All right. So if we just draw a basic curve, we've got 100 right there. All right, cameraman, if you would follow me. All right, here we go. We got 100 right here. And it's asking you, what's the probability you scored over greater than 110? So we'll put 110 right here. And it's asking you for this. And that's where we have to compute. All right. I'm going to use the formula that we've used all along for calculating z-scores, which is z, and z represents the number of standard deviations you are from the mean. And z's are going to, for a standard normal curve, is always going to be between -3.5 below the mean, or to the left of the mean, to +3.5 above the mean. And under this curve is going to capture like 99.9% of the data, right? Between 3.5 standard deviations left and right of the mean, right? And you know that formula by now. It's x, which is any x value or data value, minus the mean over the standard deviation, all right? So our x value is 110. So we're just going to go z equals 110 minus 100 over 16. And if we do the math, we come out to 0.63. So at that point, you're going to grab your nice table like this, and we're going to look on the positive side. We've got a negative side and a positive side. Positive side is to the right of the mean, negative side is to the left of the mean. And we're just going to come down that left column to 0.6, all right, down the left column. And then the tenths are down the left column, the hundredths are across the top margin. And we'll go over to 0.03, and we come up with, let's see here, 0.7357. Are we done? No, because then, if you remember, this table fills and builds from the left to the right. So that 0.7357 is this area under the curve, right? But we need the other side. In applying complementary events, binomial events, we know if I've got one, I can figure out the other because the whole area underneath the curve is equal to 1. So we're just going to subtract that from 1, and we are going to get 0.2643, which is telling me that 26.4% probability that someone's going to score above 110 on an IQ test. Okay? I'd like to mull that over for a minute and think about it. So 26.4% are going to score above 110, which also then means that what? 73.6 are going to score below it, right? So if you scored 110, that's you're doing pretty good. And that equates to, you could equate this to SAT scores we have in the past, where 500 is the mean of an SAT score with a standard deviation of 100. And that's why when you get your SAT results, it said you scored in the, let's just use this, let's say that you scored in the 74th percentile, means you're right in here, right? If you scored right at 110, right? If you scored maybe 120, or you scored 600 of the SATs, maybe you'd be up in the 85th percentile. But you can apply the same methodologies with standard normal curves with an SAT score, just like we're doing with an IQ score. Right, so that was problem number 1 for Monday. And it also asks you, what's the probability if you select someone at random that they scored below 75 on the IQ test? So applying the same mechanics. We've got our X, we've got our mean, we got our standard deviation. So we calculate that z-score or number of standard deviations, which would be 75 minus 100 over 16, which equates to -1.56. If we looked at it graphically using the same graph, let's see, we got 75, so we'll put that right here. So we'll be asking you this red area right here. Okay, 70 scored at or below 75. All right, that's an easy one. All right, and the negative 1.56 is saying is a score of 75 on the IQ test means that I'm 1.5 basically standard deviations below the mean. All right, which makes sense because it's 25 divided by 16, and it goes 16 goes into 25 about 1.5 times. All right. So the nice thing about this is what it's asking you for is exactly how the table is set up. All right. So we're just going to go to the table. We're going to go to the negative side because we're left of the mean or we're below the mean. We come down negative 1.5, and then we go over to 0.06 on the top of that, and we come up with an answer of 0.0594. All right. Now, if we convert that to a percentile with a decimal place to the left, so 5.9% likelihood that the person scored below 75 on the SAT, or actually on the IQ test. Okay. All right. Last problem. Let me get my cameraman to come down just a bit. All right. So now it's asking you, what is the probability that someone scored between 90 and 110? So let's just draw a little picture so we can kind of visualize what we're being asked. All right. We know 100's in the middle. We know 90 is below or to the left. We know 110 is above or to the right. So it's asking you, what's the probability you scored right in here? Okay. All right. So what you might recognize here is both of these are 10 points either side of the mean. So it's actually going to probably have the exact same z-score, except one's going to be positive, one's going to be negative. I'll calculate both just so that we know what we're doing. All right, so let's do this. Let's do the higher one on top because that'll make some sense here later on. So it'd be z equals 110 minus 100 over 16 for the 110, and then for the 90, it's going to be z equals 90 minus 100 over 16. I'll explain why I put the larger on the top. We do the quick math, and this was a positive 0.63. This was a negative 0.63. And we go to the table, and we get the corresponding values for those number of standard deviations we are from the mean, and we get 0.7357. Which makes sense. We're above the mean. The mean divides it right in half. We know 0.50 is to the left, so we know it's going to be larger than 0.50. And negative 0.63 is actually a 0.2643. All right. So this 7357 is from this point all the way back. And the 2.2643 is actually this open area right here, which we got to subtract out of this 7357. So we just subtract the smaller from the larger, do the quick math, and we end up with 0.4714, which is 47.1% of the population is going to score between 90 and 110, almost half. So that was the homework and carryover from what we did Monday in class. Hope that makes sense. Wish I could take some questions, but none of you are there. All right. So let me get the cameraman to roll the camera down to the right here, and then we will begin with actually today's lesson. Okay. All right. Let's zoom back just a little bit. Sorry for the squiggly lines, but these union projectionists and cameramen just are sometimes hard to work with. That's okay. All right. All right. So let's talk about what the scenario is and what the situation is, and then we will walk our way through it. All right. So you're gonna need some paper. You're gonna need that same table that we just were using. All right. And we're gonna do some calculations. I'm gonna do 2 or 3 for. I got 2 different scenarios. We're going to use the same methodology with standard normal distributions. I'm going to do 2 or 3, and then you're going to have 3 problems further on both of these 2 scenarios for due for homework for Monday or over the weekend. So let's talk about what the scenario is. All right, there's a USA Today poll, I believe it was in 2012. I kind of abbreviated this since I didn't know if I could print this out with Blackboard being on or post it on Blackboard. It's talking, it says that 25 to 34-year-olds spend the most dollars on fast food than any other age group, at least the way they partitioned it anyway, out there, all right? And it says they spend on average $44 a week, which to me seems pretty darn high. If you bought fast foods every day, that'd be average $6 a day. If you buy it maybe 5 5 times a week, that's almost $9 a day. So that's a boatload of money. And we'd fix that problem if you come into my finance class and show you how you're spending a lot of money on fast food. You can eat at home much, much cheaper. All right. And it says, so the mean's 44, excuse me, the standard deviation is $14.50, all right, which kind of makes sense. 3 standard deviations either side of the mean is going to capture most of the data. If I multiply that times 3, that pretty much brings you down to $0, or you could be all the way up to $90. If you're spending $90 on fast food, you are a rich dude, or that's just wasting a lot of money, or you're a poor dude that's not real wise with your money. But we'll save that topic for the finance class. So it's asking you, if someone is selected at random, what's the possibility they spend less than $25 a week on fast food? All right. And just like the problems we did that were a recap from last Monday, we're going to use the Z-score calculations or standard deviation from the mean calculation. All right. So let's just draw a picture. Pictures are worth 1,000 words. All right. So we got what? $44 as the mean. And it's asking you, what's the likelihood you're spending $25? Well, that's over here. I like this calculation because it's actually set up exactly how the table is, which is going to save you some money. So let's figure out how many standard deviations $25 is away from the mean. So it's always X, which is 25, minus the 44, which is the mean, over a standard deviation, which is 1450. Right? And if we do the math, and I'll have to rely on my notes, right? If we do the math, we come up with a negative, and the sign is important, 1.31. And you know the standard deviations, what's going to be negative left of the mean, what's going to be positive to the right of the mean. All right, so that's 1.3 standard deviations below the mean. So we're going to go to our handy dandy table, all right, and go to the negative side. And we're going to go down the left column to negative 1.3. We're going to go across the top for the hundredths to 0.01. And we will find that that equates to 0.0951. And that's the volume of that area in there, 0.0951, which also equates to the probability, all right, which is a nice thing. So the possibility of you spending less than $25, or the percentage of population spending less than $25 on fast food every week is 9.5%. Just moving that decimal place 2 to the right, multiplied by 100. I hope that makes sense. Okay, moving right along. Cameraman, follow me. Stage left. Here we go. Next question is, it asks you, what is the probability that you're going to spend between $30 and $50 per week? So let's do the, I'm going to do a little bit smaller graph. Hope it's big enough to see. All right, so we have the same as over there. It's $44 is our mean, all right? And we got 30 to the left of the mean because it's smaller. We got 50 to the right of the mean because it's larger. It doesn't have to be to scale. But so it's asking you for this area between 30 and $50. So we got to calculate 2 z-scores, all right? So here we go. I'm going to put the larger on the top because it makes the math a little simpler. So the first one is we're going to go 50 minus 44 over 1350. That's going to give you that z-score for the $50. We know it's going to be positive. And then we're going to do for the left side, we're going to go 30 minus 44 over, 1350. I just changed the standard deviation. It's 1450. Same on the bottom, all right? So the 50 minus 44 is a 0.41. So we're about a half a standard deviation, which makes sense because what we got? It's a difference of 6 divided by 1450, so it's about half. So we got a 0.41 for that. For $50, and for $30, we've got a negative 0.97. Don't forget the sign, right? So we're almost a full standard deviation left of the mean. So then you're going to go to your table. You've seen it. I don't need to show it again. And for the 0.41 equals 0.6591, and for the negative 0.97, it's 0.2206. All right. So that 0.6591. All right, that is really all the area from 50 all the way back to the left side of the curve. So 0.6591. And the 0.2206 is really this hollow area right here that we don't want. So we need to take that out of this just by subtracting, right? And that would come out to 0.4385. Or if you put it into a percentage that makes sense, we're just going to say 43.9%, almost 44%, is going to spend between $30 and $50 on fast food each week. Not quite half the population. I hope that makes sense. All right, one last calculation for this one, and I'm going to give you 3 to do for homework outside of class. All right, let's see here. I got to make sure I copied what I'm going to ask you to calculate. All right, so here we're asking you, okay, how much population spends more than $75 a week? That's more than $10 a day if you bought fast food every day. Same methodology. So we got 75. I'm going to go a little bit faster. We should have this down, minus 44 over 1450. All right, and if we were doing 75 real quickly, it'd be 44, it'd be 75. And so we're asking for this little area right there. All right, we do the math, we come up to 2.14. So we're almost over 2 standard deviations above the mean. We go to our handy dandy table and we get 0.9838. Which is great, but that's giving me this area here, and it's asking for the shaded area. So we subtract that from 1, and we get 0.0162, which, to put it in logical terms, 1.6% of the population is spending over $75 on fast food per week. Okay? That's a lot of money on fast food, a lot of grease. Okay. So while we're here, I'm going to have you do D homework. D is, let's see, what is D? Less than $35. Okay, you're going to calculate D for 35. Since I'm running out of room, all right. E, let's see, for E, we're going to do more than $50. Okay. Okay. All right, and F is, since you've already got these 2 values, it'll save you all kinds of work. You just got to do a little bit of subtraction there between $35 to $50. All right, so you shouldn't have to do much here because you've already got some real critical information that you obtained doing those 2. So that's your homework on that scenario. I'll give you a second to jot that down. And then we've got one more different scenario. We're talking about salaries of plumbers that we're going to do. And then I'm going to give you a couple to do on your own between now and Monday. All right, let me get that. I'll zoom in. I'll get the cameraman to zoom in just a little bit. So you're going to do D, less than $35. E, greater than $50. F, 35 to $50. All right. You got it? You guys are awful quiet today. I guess because no one's there. All right. So let's do problem number 2. We're going to change the scenario, but we're going to use the exact same mechanics and methodologies that we used on these previous ones over here, and those ones from with the IQ scores that you had done, started on Monday, finished for today's class. All right, so here's the scenario. Average, and this is 2011, 2012 data, so it's low, but we're going to go with it anyway. Average or mean, that's what AU is, salary of a plumber is $47,350. I know plumbers that are making 6 figures, but for the sake of argument, it's $47,350. Salaries are normally distributed, so we can use all this normal distribution stuff to solve some probability problems. And this is not a 6, that's a standard deviation. This scenario is $5,250. All right, so the first question says, what percent of the plumbers earn below 30,000? All right, so I bet you can probably do this one with your eyes closed. All right, so nothing's changed on the mechanics of how to solve this. So we're going to take X. Actually, let's draw a picture. Let's draw a picture. So of what this asking is. So we got what? 47,350 for the mean, right? It's asking you what percent's making 30K. All right, there's 30K. I'm gonna abbreviate just because of space. So we're gonna go 30, I'm gonna abbreviate again, 30K minus 47,350. That's our mean over, that's our X, over the standard deviation of 5,250. Okay? And if we do the math, bada bing, bada boom, you come up with negative 3.30, which makes sense because 30 minus 47 is 17. That goes into it about 3 times. So you know it's going to be a very small number. That's almost off the graph since it's 3.5 standard deviations either side. So if we go to the negative side of our handy dandy table number 3, and we look that up, as I projected, you come up with a super small number, 0.0005, or 0.05%. So good thing no one's, or almost nobody's making below 30,000 bucks. All right. Hope that makes sense. All right, cameraman, follow me. We're going to go a little bit further left. And if you would give me just a short minute, I had to use this space to calculate that work that we carried over from Monday. And now we are going to do the second part of the same problem set 2. All right, I'm not going to switch to black ink, but for B, we're going to calculate, let's see, what's the percentage or probability that they earn more than 63K. Now we're getting up to always a little bit different, a little bit more respectable. So if I do the graph for this, we still have the same, what, 47,350 for the mean. And we're looking at 63K. It says more than that, so we're looking for this area. So we're going to do a little extra math because the table is going to give us this area, right? Same mechanics. So we got 63K, abbreviation, minus the 47,350 over the mean, which was 5,250. Okay, and if we do the math of all that, we come to 2.98. And we know it's going to be positive because everything to the right of the mean, those z-scores are always going to be positive. All right, come on a little bit closer. You guys are too far away from me. All right, go to our handy dandy table number 3. We get 0.9986. That's the good news. But that's all this area over here. I need this area here, so we subtract that from 1. I'm not going to write it down. And we get 0.0014. And if we convert that to a percentage, it too is very small. 0.14% of the population earns more than 63,000. I'm sure it's much higher than that right now. Okay. Questions, comments, concerns? Hearing none, we'll move right on. Okay, here we go. All right, so you got these 2. Now I'm going to have you do C for homework, and a D, and an E. All right, stick with me, cameraman. Just kind of dozing on. All right, so the first one is, what? I don't want to do that. Yeah. All right, what's the probability that the plumber earns less than 35K? Okay, I'm going to abbreviate 35,000 bucks. That's what the case stands for, right? For C, we're going to do greater than 50K for D. And just like the problem over there, for E, we're going to calculate what's the probability of earning a salary between those two. So between 35K to 50K. All right. So you got these 3 here to do. Hopefully you've taken good notes. And you got the 3 over there to do, and you've got good notes for that. You've got your handy dandy table to use. Negatives on the one side, that's left of the mean. Positives on the other side, that's to the right of the mean. Okay. Draw, always a picture's worth 1,000 words. I encourage you to draw a little graph of what you're being asked, excuse me, because I think that clarifies what you're being asked to solve. And let's see, if you run into difficulties, hopefully you've got your handy dandy little guide that we created on Friday a couple weeks ago. This actually is right out of section 6.2, is it? Yeah, 6.2. So this is a little bit kind of quick and easy guide or reference to use, but the same thing is actually in your textbook. Okay, so that wraps up Wednesday, April Fool's Day, and it also is going to wrap up section 6.3. So have those six problems done for class on Monday. If you want to drop them in Dropbox or just shoot me an email of them, that would be great. So I can see that we're all operating off the same sheet of music. If you want to get ahead of the game, we're going to start section 6.4 on Monday, which is known as Z notation. All right, check in with me during office hours, Monday through Thursday, 2 to 2:30. You got to check in at least once a week and come to both classes. And also on Friday from 9 to 10. In the meantime, have a good weekend. Stay 6 feet apart from everybody. Wash your hands nonstop. Don't touch your eyes, ears, nose, and throat, and mouth, and all that stuff, because that seems to be the way to catch this galloping crud. And I hope everybody else is well, and we'll see you on Monday, if not before.